Hello, everyone. I think it's time we can get started right now. Thank you for joining me for today's quick presentation. This should take about a half hour on how to manage frost risk with HOBOnet remote monitoring system. Before we get started, just a couple of housekeeping items to get through. If you have any questions, please feel free to enter them at the bottom in the questions section of the GoToWebinar control panel. This webinar is being recorded, and you will get a link emailed to you to access this recording in the next couple of days or so. Hosting you today, I'm Richard Rodriguez. I joined Onset back in 2019 to lead the outdoor and agricultural markets. For anyone that is not yet familiar with Onset, Onset has been leading data logger and sensor technology since 1981. So we've been around for quite a while, and our products have been time tested and are trusted for reliability, mainly in the research field. A lot of ecological, environmental, and agricultural researchers have come to love our products, and in the past few years we've adapted a lot of those to more commercial settings. We do have a global network of distributors, so our products are available to everyone, regardless of where in the world you may need them. Our agenda. So again, this should take about 30 minutes, give or take, and then we'll have some time for questions at the end. We will start with a quick overview of frost, and then we'll cover a few frost mitigation methods. We'll focus on the two that we see our products tied to more frequently, and then I'll give you an introduction to HOBOnet, provide you a couple of customer examples of our actual real-life uses of our products and the results of those products, and then I'll show you how easy it is to actually get these things set up. But before we get going, I'll cut off my camera just to make sure that there is no lag because of bandwidth issues. All right, so for anyone working with crops that bloom early in the season or have late in the year harvests, these crops face frost risks, and frost can really lead to large losses that be very costly. So they tend to keep a lot of growers up at night. Understanding how frost occurs. We'll cover a little bit about how frost occurs just to better understand the mitigation methods and when these are actually can be successful and when they're really not successful. So typically on typical days you have temperatures are warmer or warmest close to the ground, so right around where your crops are growing, whether they be trees in an orchard, or you get that those higher temperatures around your crops, and then temperatures drop as altitude increases. Warm air is lighter, so it tends to rise, to replace with cold air, and you have this constant movement of air. At night, however, you don't have the sun warming up the surface, so you don't get this this transfer of energy onto your crops and the soil around them. On cloudy nights, this energy is reflected back towards the clouds, but then the clouds push that energy back towards the ground, so you don't get as much cooling. However, on clear nights, where the sky is clear, that energy is lost into space. So temperatures near the surface tend to drop, forming a layer of cold air near the ground with warmer air trapping it up above, as you see on the right-hand side of your screen. On windy nights, the air is pushed around and it mixes, so you get cold air and warm air mixing a little bit, so the risk of frost is reduced. On still nights, however, especially if the air is really dry, like you tend to get late in the year and through the winter, that cold, dry air will cause the drying of crops, of especially fruits, berries, and this can lead to that frost damage. Where you, in situations where you get this cold air trapped by a warm air layer right above it, that's known as an inversion. And that typically you see that that height of that cold air column to be at around about 30 feet in height and can extend up to about 200 feet. So there are several methods for preventing frost or frost damage. We'll focus on the two here that we see our HOBOnet systems combined with most frequently, those being wind machines and irrigation. So I assume most of you are familiar with this, but in wind machines, you're pushing warmer air from that inversion layer down onto the crops to replace that cold air surrounding your crops. With irrigation, you're basically trying to create a layer of ice around the fruit or the bud to keep the temperature from dropping below that freezing point. So the actual freezing of water around the buds or fruits transfers energy into the fruit. So while these are effective, there are challenges or problems with running wind machines or irrigation pumps. There's a large cost to that, both in terms of money and in time. So your options really are to stay up all night, looking at a thermometer, seeing what the temperature is outside, and hopefully correctly accounting for the temperature differences between the thermometer and the location that you're looking at and what the actual temperature is out in your field. On one thing about these frost nights when there is really no air movement, the sky is clear, there are very large temperature variations from point to point. We have one cranberry farmer that works with us in the area that talks about having an 11 degree difference from the road along his bogs to the actual bogs themselves. You can spray water or run wind machines based on a weather forecast, but we know that weather forecasts aren't always accurate, and they may be based off of weather stations that are not close to you. And again, temperatures can vary widely from place to place. So this can lead to you running your equipment needlessly, which wastes time, money, puts a lot of wear and tear on your equipment. And for wind machines, you may also want to confirm that there is in fact an inversion, that you do have that warmer layer of air at that 30-foot height, give or take, before turning them on. Also, running them too often can disturb your neighbors. Now, of course, a big reason to invest in this, in addition to time and allowing you to sleep at night, is money. So looking at a specific customer of ours, we were talking about what the costs were for him to run these pumps all night. And in his situation, he's got a mix of propane and diesel engines, and according to him, in a 10-hour frost night, he'll go through about 8 gallons of fuel per pump at a cost of $2.80 per gallon. He estimates he spends about $224 per pump per night. For 11 pumps, this comes out to $2,500 per night. So quite a large cost for what is relatively not a very large operation, but costly at that. And then one thing that I forgot to mention, this is fuel alone. I really didn't. This doesn't include the cost for maintenance. So after running these pumps all night, there may be maintenance costs involved, and depending on where you're located, you may have costs associated with the actual water usage. So our solution to this is HOBOnet. So with HOBOnet, you can monitor temperatures across multiple points in your field with a single system. So with one station, one data plan, you can spread out temperature points at different places so that you can really cover yourself and know pinpoint where that cold, that frost risk really may be. You can also, this can then send you an automated text message alert to your phone so that you know in the middle of the night, hey, it looks like frost is imminent, it's time to turn on the pumps. You can actually have the system set up to automatically trigger that action. Have our RX3000 station initiate a pump for you. So at the same time you get a text message, you know that your pumps are starting up so that the irrigation is kicking in. And so what does HOBOnet look like? At the center of HOBOnet are the two stations. So depending on what level of needs you may have, you have two options at two different price points. So to start, we have the RX2100, which provides the lowest cost option, suitable for most applications really. So you can get started for around $700 for the station. And you can start to monitor conditions both at the station and again remotely, as mentioned. This station is available in only a cellular type option, so you can choose from any one of our 3 cellular data plans, which come at a yearly cost starting at $150 per year. And then the more complete solution, the RX3000, which has a few more bells and whistles or options that you can go with, from a Wi-Fi or Ethernet connection to that cellular connectivity. It also combines, allows you to combine remote monitoring of temperature, soil moisture, and any other measurements you may need with water level. So if you at the same time want to monitor water level, whether it be in tank or pond, this can combine that for you. You can also measure flow of water in pipes. And again, add a relay which can automatically trigger the start of a pump for you whenever an alarm is received based off of a threshold that you set, that you choose, which we'll actually get into that in detail in a few slides. In terms of temperature sensors or what you would need in addition to the station for frost protection, you're really looking at only needing either a temperature or temperature and relative humidity sensor. And you can go with a single point, add up to 50 of these per station to really, again, cover yourself for different crop types, different locations on your farm, however you may see fit. And again, you would get these would as soon as they sense a temperature that you would tell it to set as the threshold, you would get a text message or email alert. And now diving into the actual uses. Cranberries, given our location in Cape Cod, Massachusetts, where we develop and manufacture all of these great products. Cranberries are, I believe, the largest crop, but the most common crop. Now these do bud early in the year and they are harvested quite late in the year, so starting late September through early November, which leaves them at risk of loss due to frost. When they ripen, they are capable of withstanding rather low temperatures of up down to 23 degrees Fahrenheit. However, that late in the year in New England, you can get quite below those temperatures, and especially in cranberry bogs, which tend to be set lower than the area surrounding them. one thing about cold air on still nights is that it flows like water, basically. It will flow and find the lowest point to settle, much like any liquid would. And bogs being recessed below the roads around them, that cold air will find those bogs and just sit there. So looking at the most simple systems here, we have one customer with a small operation, a lot of, though small, this is a farmer that would like to be able to rest at night, not worrying about whether or not he should run a pump at $224 for the night, or stay up all night waiting to determine whether or not that is needed. So for this operation, a single station was used with a single temperature point. Given the layout of the farm, given his history operating on these bogs, he had a good feel for where frost damage was more likely to occur first. And so, as you can see here on the map in his account, the temperature point was set at that point where he believed frost was more likely to occur first. So whenever temperature dropped below his threshold there, he would get that alarm. And what does something like this cost? So the most simplest systems, so the initial investment for the first year, $1,200, and that is including a rather high data plan. You could actually reduce this by $100 if you don't need to get your data so frequently. If you can wait 15 minutes for updates, you could lower that. But even at that $1,200 level price point, knowing that the cost to run one of these pumps is about $224, really you're looking at paying this system off after avoiding 5 nights of running a pump needlessly. And of course, this payback would improve greatly with the addition of any pump, or any pump that uses would use more than that 8 gallons of fuel. In the example of that first customer that I spoke about, he's looking at 11 pumps. So in one night, he could pay off one of these systems. Moving on to our next customer case, Fishkill Farms up in upstate New York. So this customer actually approached us originally not looking for a way to monitor frost risk. This customer was looking actually to build a weather station that could tie into NUA's free pest monitoring system. NUA is a crop and pest model service offered by or started by Cornell University, which will take data from a weather station on your farm and that is then uploaded onto their service. So then you can get hyper-local crop, pest, and irrigation forecasts, along with advice on how to manage these threats. If this sounds of interest to you, please don't hesitate to reach out. We can put you in touch with the right folks to get set up. For most states, this is actually a free service. But after this farmer reached out to us and looking at what more our weather stations can do with the addition of the HOBOnet capabilities, they decided to add temperature measurements for frost monitoring, some soil moisture points, so that they could also experiment with improving their irrigation decisions and planning. They wanted to monitor their greenhouses, and also they did cold storage on site, so they wanted to be able to monitor their cold storage facilities. And so their map looks something like this, where down by their greenhouses and cold storage facility, you get a cluster of sensors, and then you get a couple of temperature points farther out for a couple different crop types where they feared that risk of frost was greater. The starting price point for a NUA capable weather station is just under $1,900. However, as mentioned in the use case we just talked about, after this, they added quite a few capabilities and ended up more closer to that $5,000 range for all the bells and whistles, cover their entire operation with a single system. The great thing about it is that they were able to do it with a single station, and which allowed them to do everything for a single data plan. So for $100 to $250 per year, they're able to monitor this and have peace of mind that everything is running on their operations are running smoothly. Now moving away from irrigation to the use of wind machines, you're really looking for the same concept and setting up the alarms based off of whatever temperature you're looking to start the mitigation practice at. However, with wind machines, you want to add a second temperature point, which would need to be at about 30 feet in height. And what this is for is just to confirm that you're looking for that inversion. You want to make sure that the air temperature at that 30-foot level is in fact higher than the temperature at your crop height and not lower, which would make turning that wind machine on a bad idea. Now let's look at how easy it is to pair these devices. So say you get your station and a single temperature point for monitoring. When you open up your station, you have a single LCD screen with 3 buttons. If you have 2 options for temperature points, you could do a plug and play sensor, which is our lowest cost, easiest to use sensor, where you plug it into the bottom of the station and nothing else is needed. If you're doing a wireless sensor, you would click on select until you see this module 1 pop up, or whatever module you have the wireless manager plugged into, and then you would click the cloud button. That would put you in search mode, as noted by the magnifying glass. Once there, that means that the station is looking for any wireless sensors trying to join the network. When you open up your sensor, again, you have a small LCD screen and a single button. You press and hold that button down for 3 seconds. You get a signal strength indicator flashing. That will flash until that finds the network. Once it finds the network, it will stop flashing, and that X will begin flashing during setup. So it by itself does its own setup. That could take up to 5 minutes. Once that is complete, the screen will look like this with no X. That will tell you that it all is good to go. It really doesn't get much easier than that. And now we'll quickly go over what setting up an alarm would look like. Oh. There we go. All right, so in this account, we have several stations. We'll pick one here we have ready. And so on this station, as you can see, we plugged in 2 temperature sensors already, and we have a relay module. So each relay module will have 3 relays, meaning that I can control 3 different circuits with a single module. So let's say I don't have anything on this second temperature point. Actually, before we do that, let's look at setting up a relay. So you go into the relay, click that wrench there. You can label this whatever you'd like. So let's call it apple pump. And you tell it what you want the normal state to be. So you can decide to have it open, meaning that the pumps are off, or closed and have something running normally. And you also have the option to control it manually and say, hey, I want you at the next call, or the next time the station connects to the cloud service, I want you to open or close. So we'll leave it as it is here. Go back to the device. And now we come to our temperature point. So let's say that this is the temperature sensor that we have deployed out in the middle of our apple orchard. We'll come to the alarm symbol, and then you have several options here. So you've got the devices identified here, and then you're going to tell it whether you want an alarm to be sent whether a temperature goes above or below a specific point or outside of a range. So at Fishkill Farms, for example, we talked about them doing cold storage monitoring for their crops. They could actually benefit from having a temperature set, an alarm sent out if temperature goes below a desired point or above a desired point. So, they want to be sure that the refrigerators are running as intended and don't break down, but also don't freeze all their crops. So let's say here, if it goes below 32 degrees, for 3 logging points. So we have this logging every minute. This means that if the temperature drops below 32 degrees for 3 minutes, an alarm is sent. And then you also set the clear condition, meaning at what point is that alarm condition no longer in place. And you want to set that temperature slightly different than what you set your alarm temperature at, just so that you don't get, if the temperature is right at that 32 degrees, you don't get a consistent on-off type scenario. So we'll call that 33 degrees. And then I don't want to get an email because I don't check my email while I'm in bed, but I would get a text message, enter my phone number here, you can add a second action to also close relay pump 1 or Apple pump. And then with that, we know that I both get a text message and my relay initiates. And it's basically that simple. We do have much more detailed instructions. It doesn't get much harder than that, but if you're actually interested in learning more, we do have videos, additional videos, and we do have a great team of folks ready to help you make sure you make the right decision, and that not only make the right decision, but understand if HOBOnet is the right solution for you. So with that, I'd like to thank everyone for your time. I'll open myself up to any questions you may have. My colleague Jessica, which you heard at the start of the call, will help join me to answer any questions.
Hi, Richard.
Hey.
We do have a couple questions here. So what is the communication range of HOBOnet, and does it require direct line of sight?
So with direct line of sight, the range is 1,500 to 2,000 feet. Now, the HOBOnet uses a self-healing mesh technology, so you can do up to 5 hops, meaning you can go 1,500 to 2,000 feet line of sight from the station to the first sensor, but then from that sensor you can go another 1,500 to 2,000 feet to the next sensor. So if you don't have clear line of sight and you have buildings, hill, whatever it may be, obstructing that line of sight, you can actually that can just slightly decrease what that range is, and you'll need to place a device within 600 feet or whatever it may be at a shorter distance, or you can just use devices to create hops to get around an obstruction.
Great, thank you, Richard. And if you could just repeat, Brent asked a kind of follow-up question. How far away can a sensor be placed? I think you mentioned the distance, but if you could say it again.
So with line of sight, easily 1,500 to 2,000 feet. And we do that at 6 to 8 feet in height for the sensor that we recommend them being installed. And again, if you need to, you can do so. You can really get in a radius from set up as a radius from the station to the farthest out sensor. You can get up to 7,500 feet. which really allows you to cover a wide area. Of course, in most cases, you've got obstructions in the way, so getting that distance will be difficult. But again, you can use additional sensors to create hops around a building, for example.
Great, thank you, Richard. Here's a question by Long. He asked about what you need to automatically trigger the pump for the alerts. You mentioned that earlier on in the presentation.
Yeah, so basically you would set your thresholds to initiate the alarm condition. So when that alarm triggers, your sensor will actually pick up on that alarm and initiate a call to the HOBOnet, to the HOBOlink service, our cloud software. So you would get the alert, and that would also tell the relay module on the station to perform an action.
Great,
now, the
thanks.
actually wiring and integrating that, we'd have to look at what the specifics are there.
Great, thanks, Richard. Here's a question. Can we use a repeater to boost the signal for long distance?
Yes, we do have repeaters. So that would be if you don't need any additional sensors, you can use a repeater, or you can just add a new sensor. All of our wireless sensors act as repeaters. But we do have a repeater which would be the lowest cost way to extend that signal.
Thanks, Richard. That is all the questions I see coming in for now.
Great. Well, I want to thank everyone for your time. On your screen is the contact information for all of our global sales leads. My name is at the top. If you do have any questions about anything we talked about today, please do not hesitate to reach out. I do enjoy talking I would enjoy talking to all of you. So with that, I hope everyone else is enjoying their week. Have a great day.